Alors, bonjour tout le monde, bienvenue à la session Transport et logistique. La dernière présentation de la journée sera donnée par M. Asad Lesani de Blue City. La présentation sera donnée en anglais uniquement, mais elle sera accompagnée de diapositives en français. Donc, sans plus tarder, our next presentation will be given by Mr. Asad Lesani from Blue City. Mr. Lesani received his bachelor's and master's degree in electrical engineering, specializing in control systems. He has a PhD from the Department of Civil Engineering at McGill University, focusing on developing multimodal traffic monitoring systems. His research and professional experience include intelligent transportation systems, sensor design, transportation safety, optimization, and control theory. He is the recipient of several awards, including the McGill Engineering Doctoral Award, IVADO Postdoc Fellowship for Entrepreneurship. He founded Blue City in 2018, a company that has built an AI-powered real-time multimodal traffic monitoring and data analytics systems. It uses Lidar technology. So, without further waiting, Mr. Lesani, the floor is yours.
Introduction. Hello, everyone. I'm super excited to be here today and presenting Blue City. I'd like to thank IVADO team for organizing this event. And I'm really honored to be a recipient of IVADO Postdoctoral Fellowship on Entrepreneurship back to 2019. That was very helpful to push commercialization of our technology, and I'm really grateful for that. So, talking a little bit about myself, I did my bachelor and master in electrical engineering, focusing on electronic design, sensors, and control theories. And then I did my PhD and postdoc at McGill, but this time in the field of transportation with focus on sensor design and traffic monitoring applications. As a part of my research, we found that most of the existing technologies are, for traffic monitoring specifically, are unreliable, costly to install and maintain, and typically generates limited traffic data. For traffic operation applications, we need a technology that provides 24/7 data in all weather and lighting conditions, and that's why we see technologies such as inductive loop detectors, radar, and radar-based technologies for those applications. But those products mainly provide data about vehicles. On the other side, camera-based technologies offer enough resolution to provide classification of the road users in a multimodal traffic network, but typically camera-based solutions suffer from the lack of the reliability and accuracy in low lighting and adverse weather condition, where most of the more than 75% of accidents happen during those scenarios. And a camera always comes with a privacy concern. Addressing the data needs of the different stakeholders in a municipality requires installation of different type of technology, each proper for a specific application. And even with all those technologies, city needs to process the data to convert it into insight that they can use it in their daily activity. But many municipalities, they don't have enough resources, so they have to hire another firm to do analysis for them, which makes the whole project even more expensive and inefficient. So to address those concerns, our company has built a LiDAR-based traffic monitoring and data analytics system that works in different weather and lighting conditions. This enables us to use this solution for traffic operation applications as a replacement of radar or inductive loops, can detect, classify, and track all road users, including pedestrians and cyclists, and in most of the cases with a single sensor at the corner of the intersection that reduces the cost of the installation and maintenance. And it's already powered with 5G technology that enables us build innovative application on top of our solution, such as sharing the data in real time with connected vehicles. And all these capabilities without raising any privacy issue. So let's see how it works. So when you install a LiDAR at the corner of the intersection, it generates real-time 3D image of the intersection emitting hundreds of thousands of laser beams every second. This allows us to construct 3D shape of the object within centimeter resolution. Each line in this video demo represents a laser channel, And within each line, we have thousands of single points, each represent a distance measurement. Unlike a camera, Lidar actively measures the distance to the object, which means that there is no need to calibrate the Lidar for applications that we need 3D sensing. In a typical installation, Lidar is connected to our edge box using Ethernet cable. Our perception software reads frames of Lidar cloud point data. Then it detects the object, classifies them, extracts the trajectory of the road users. This is basically the core of our technology that happens in real time just at the intersection. So there is no need to have high bandwidth network infrastructure to transfer raw Lidar data and do cloud computing. Then extracted data is passed into different layers of the applications that I'm going to talk about a couple of those use cases. We're following an open API concept that provides access to frame-by-frame location of the object, the classes, size, and unique ID associated to each object in real time. This API can be used by our partners to build their own application on top of the solution. And since everything is processed at the edge in real time, so we can easily meet low latency requirements for applications that decision-making should be fast and reliable. As a primary use case of our technology, we're targeting intersection monitoring as the first application. There are more than 100,000 intersections in North America with a traffic monitoring solution, mainly inductive loop detectors that buried under the pavement. Those mainly provide limited data about presence of the car, not other type of road users. Has a high maintenance and installation cost. Installation typically requires road closure and even reduces the lifespan of the pavement. So those sensors typically have average of 5-year lifespan and are essential part of the city operation that should be replaced right away after their lifespan. So this is our first target market, which worth more than $7 billion opportunity in 10 years, just in North America. So using our solution, we can define customized virtual loop detectors. Our customers can use this system as a replacement of inductive loop detectors or radar. But what makes the solution even more interesting is the fact that you can extend those virtual loops to other type of road users, including pedestrians and cyclists. That means that the traffic light controller can use that information to extend the red light for cars if needed to make sure that pedestrians cross the intersection safely. So this is the way that we're changing the way that we structure the traffic monitoring and management in general, and expanding from just considering cars to having taking into consideration other type of road users, including vulnerable road users. And this is another opportunity that we can use to use this data and convert into standard safety messages and share with connected vehicles. And as you can imagine, this is technology that can be easily adopted for other applications that requires accurate and reliable multimodal object detection, such as railway crossing, trespassing monitoring, intrusion detection, among many other other type of applications. So all the data that we are generating with our perception software is passed into our cloud analytics. That is where we provide a SaaS platform which generates ready-to-use insights on road user safety and behavior. Another application or solution generates real-time speed data for all objects at the intersection, which then this data can be used for driver behavior analysis, traffic light timing efficiency, and even study overspeeding and effect of weather and lighting condition on the road user speed pattern. And again, like this is another step that there are opportunities to work with university partners, especially to build their own application using different layers of the APIs that we provide with our technology. One of the most exciting application that I'm going to talk about is a real-time safety analytics platform that we are building on top of our solution. Typically, the safety of the intersection and other traffic facilities is most often assessed by tracking and analyzing police-reported motor vehicle crashes over time. But given the infrequent and random nature of crashes, this process is slow to reveal the needs of remediation. An alternative solution is a proactive approach in studying road user behavior known as surrogate safety analysis. There are companies offering similar services, but those are dependent on using cameras that typically installed temporarily. So the analysis won't capture a long period of time to identify the root cause of the safety issues at the intersection. Additionally, as I mentioned, more than 75% of road accidents happen at low lighting condition where camera-based solutions fail to provide reliable data. But in our case, this analysis will be available 24/7. So now let's see how it works. Our algorithm analyzes the trajectory data of the road users in real time to measure different metrics, including post-encroachment time. PET is a factor that is used as a measure of conflict and is highly correlated to the risk of accident at the intersection. As you see in this demo, our algorithm identifies the conflict point between those two pedestrian and car. Then the difference between the time that the pedestrian leaves the conflict zone and the time that the car gets to that conflict zone is measured as a PET. The lower PET value, more risk of accident at the intersection. Our safety analysis engine stores all these PET values based on their timestamp, type of turning movement, and class of the object involved in that conflict. Then the user can visualize that information in our dashboard using interactive heat map with filtering option based on the type of road users, turning movement, to get more details about the root cause of the conflict at the intersection. Then the user can proactively identify high-risk intersection and plan to solve the safety issues. Again, this application is not just limited to intersection monitoring. It can be used for other type of road users, including railway crossing safety applications. And again, all this information that I mentioned will be available through our APIs as well. So all the video demos that you saw here is based on our current version of the system based on a 32-channel Lidar. But I'd like to talk a little bit about where this technology goes, why we are so excited about Lidar. This video demo is from a 8-lane per each approach intersection, which is fairly big intersection. And for this video demo, we used a 128-pixel channel Lidar instead of our standard 32-channel. And not only we can get higher resolution, we can get richer information about classification in a longer range area, which opens up a lot of other opportunities, which reduces the cost of the sensors, cost of the installation, and we can get a better coverage, which is going to be very important for building digital twins application. We're actively involved in 2 projects in the US, one with Department of Energy and the other one with the Department of Transportation in New Jersey, that we're going to use this version of Lidar to build a digital twin. And the whole idea for one of the projects with DOE is to how we can use this information, share with connected vehicles to offload some of the processes that it's happening in autonomous vehicles down the road. So potentially we can offload some of those processes, which leads to reduction in the fuel consumption of the autonomous vehicles as well. As a summary, the reliability of Lidar technology, our perception software, our open API, and 5G technology opens up different opportunities that we don't see in a typical traffic monitoring use cases, such as sharing pedestrian data with connected vehicles, detecting pedestrian crosswalk, especially in area with high elderly population, and improving the accessibility for all road users, and potentially use this technology for incident detection, emergency dispatching, and many other applications that our partners can build on top of our solution. We are, again, we are actively involved in different research opportunities. We're working with the University of British Columbia for a project that they are leveraging from our APIs. And we are looking into other collaboration opportunities with researchers and private partners to use our technology in different innovative applications. So talking a little bit about the business side of the company. So over the past 12 months, we've seen a lot of interest in using our technology that is reflected in our fast growing traction globally. So our company generated more than 500K in sales just over the past 12 months, which is growing quickly. And we recently got about 300K grant from government of Quebec to implement our technology in 20 intersection, which is going to be the biggest project that we're doing in Canada. So with a city partner in Quebec, which again, like that project will also opens up a lot of opportunities to work with researchers because we're getting a lot of data with the good coverage with our sensors. So we built really strong partnerships with firms such as Rogers Communication, Velodyne, and transportation consulting firms. And with like implementing 5G in our technology, we see a lot of opportunities on using this technology powered by 5G. And we're in active discussion with companies like Verizon, Siemens Mobility, because they see a lot of potential in not only the technology, but also the concept of open API that we built. So to accelerate the growth, we're raising $2 million USD to expand our R&D and sales and marketing team and protect our IP. So we already secured about half of this round with a public Lidar manufacturer. They're investing in our company. And we are also looking into potential investors and VCs that if any of you guys can help with that, so we would be happy to discuss. So that's my presentation. I would be happy to take any questions.
Thank you very much, Mr. Lesani. Very interesting. Of course, there are some questions. Immediately, I would have some, but just for a starter, is the MTQ, Ministry of Quebec of Transportation, aware of your technology, and SAEQ also?
Not yet. So we had a discussion really at the earliest stage with MTQ, but definitely we would like to have another conversation with them. It was like 2 years ago, but yeah, so we would like to talk to them. Yeah. And
what are the biggest collaboration challenges you have met so far? Starting.
Yeah, I think there are opportunities that like we are going toward making our roads ready for connected and autonomous vehicles applications. I think one of the values that this technology is bringing, and there are opportunities to work together, is with collaboration is on how we can potentially use this technology not only just for a traditional traffic monitoring, but also how we can digest this information for more advanced systems, like applying AI as a traffic management. We are doing traffic monitoring, but we're not involved in traffic management, like optimization of traffic light timing. So if there are researchers that they are doing in that, like doing research on using AI for optimization of traffic light in larger scale, so that's the part that I think there are opportunities to work together. And also, again, like applying this for other use cases, like as I quickly touched about railway crossing monitoring. There's a big issue for our supply chain with the safety issues at the railway crossing or trespassing. That again, like this could be, there might be some opportunities to work with third parties.
Yeah, maybe can you expand a little bit more on the opportunities, because we saw a lot of traffic management, but you also mentioned intrusion detection and application. Yeah,
so one of the projects that we are working with one of the consulting firm is intrusion detection for a as some sort of geofencing that we can geofencing that we can use this technology. So let's say if there is intrusion, or if someone is walking toward, like, let's say a railway, and then we can potentially identify like generate some alarm or warning system for those type of application. This is one of them. The other one, we did when I was doing my PhD, we did a research project with Transport Canada on railway crossing monitoring, because first, they don't have any information about what's going on railway crossing. Second, how we can potentially use existing technologies or like this type of technologies to have a warning and share it with, let's say, upcoming trains that there is a car, let's say, stopped on railway. So we're not directly working on those applications, but we are really open to have conversation with any researchers or third-party companies that we can build these type of use cases on top of our solution.
I have a question here from a participant asking approximately what is the cost of monitoring a single intersection for a whole year as a bundle?
Yeah, so typically the way that we structure our price is typically competitive with the existing solutions. Let's say if I want to compare, if you go with the radar-based solution, it costs about 30,000 per intersection. They need one per each approach typically. So with our solution, let's say fisheye camera technologies, the price is something between 20K per intersection, but we're not charging right now yearly subscription. So our SaaS platform, we're just giving for free for now. But the way that we structure is that if they want to get right now the sensor per intersection is something about 20K per intersection. So and typically it's a 5-year. So over the 5-year there is no other cost for it.
That's interesting. And you need 1, 2, 3, one each approach. And would you provide the data analytics or the dashboard to do it? What's the final point of your work?
Yeah, so right now, like typically one sensor covers the whole intersection, but we have some intersection that they are big, so we might need 2 of them in max. So we don't have any intersection more than 2 required for covering the whole intersection. Most of the cases it still is 1 sensor. So we do provide access to our analytics. Right now it's for free, but down the road, let's say a year, by end of this year, so for our new customers, they're going to be like a monthly cost for having access to those analytics that we build. But if they want to just use our API, if they want to just grab the data, so from the sensor or connect it to the traffic controller, there is no cost around that.
Because there's 2 minutes left, I think there's very important stuff to go through, but I will try to resume. Where would you see yourself in 5 years from now, for example?
Yeah, so I think we have a really important mission on saving lives and making our traffic efficient, and then ultimately wasting less time in traffic congestion. So what we want to see in the next 5 years, we want to be one of the main technology providers, hopefully with worldwide traction on using and leveraging this technology to help municipalities to improve safety and mobility in road networks.
In that sense, would you say that your technology is ready for the market, but the major obstacle would be the adoption rate or the willingness to go for innovation inside cities, municipalities, or?
Yeah, I think the timing is really interesting for innovation, especially like if you take a look at the infrastructure bill passed by Government of Canada or the similar infrastructure bill passed recently by government of US, I think it's something about $3 trillion. So I think the timing is right. So it's just a matter of pushing this technology, and that's why we are raising seed capital.
So thank you very much, Mr. Lesani from Blue City.
No worries.
I remember this name. Time is over, so we'll go to the conclusion of this day. But please take some time to interact with the speakers. Maybe you still have time, get their address and talk to them.